Welcome to the third part of Chapter 18. In this part of Chapter 18, we're going to be focusing on conductors and insulators. What I want you to do is take a moment and think to yourself, what is a good conductor and what is a good insulator for electricity? Okay. And let's make a list. So hopefully the thing that comes to your mind for conductors right at the top of the list is copper. That's what our wiring is made out of. Gold is also a very good conductor. Aluminum isn't bad, and forgive me, I don't know how to spell aluminum properly, so I'm just going to use Al, the scientific symbol for it. Over here in insulators, hopefully you're thinking things like plastic, maybe rubber, like the tires on your car, wood. So it looks like we have this differentiation between metals and non-metals. And in general, that's a pretty good distinction. The one that isn't on here that you probably want is water. So is water a good conductor or is water a good insulator? And you're probably thinking, well, Dr. Murphy, don't be silly. But let's take a moment and look at water really quickly. Okay, so to look at water, what we're going to do is we're going to look at a simulation, which I have open right here. So the first thing I'm going to do is I'm going to take just pure water and put my conductivity sensor in here, and we see that nothing happens. Okay, so let's take that back out. Let's add some sugar to the water. I know, I'm being silly. There goes some sugar. Bring my conductivity sensor in. Again, nothing happens. It's not conducting. Okay, so let's remove the sugar, remove the sensor, and now do the thing that seemed obvious from the start, hopefully, and add some salt. And now when I bring the conductivity sensor in, we see that the light has started to glow a little bit. So what's going on? Well, it turns out pure water on its own, is not a good conductor. It's not a good conductor. Okay. Sugar, not a good conductor. Salt, on the other hand, when you add salt to water, all of a sudden it becomes a good conductor. So let's look at what happens on the microscopic scale when we look at what happens to sugar. If I can get some here. Okay, so we see the rather large sucrose molecules there, and they go into water and they break apart, but they break apart into sucrose molecules, just individual ones instead of big clumps, if you will. Okay. Overall, these things are neutral. Okay, so let's remove that. And now let's add salt instead. Remember, salt is sodium chloride, NaCl, and when that goes into water, the bond for the salt molecule breaks or disassociates. I'm not sure which is the correct word here, but you can see all those little sodium atoms and all those chlorine atoms, but it turns out that's not a sodium atom and it's not a chlorine atom. What it is it's a sodium ion and a chlorine ion. So the electrons associated with the two atoms don't stay with their parent, if you will. They go with the other one to provide a positively charged ion and a negatively charged ion here. And those ions are what makes salt water conduct. So, is water a good conductor? Well, the answer is no, but maybe. Okay, so let's think about this for just a minute. Okay, pure water is a poor conductor. How pure is your water? So, things to think about when dealing with water and electricity. Water and electricity does indeed equal bad. Please do not take this little discussion as a invitation to take a bath with your favorite electrical appliance. This is not a good idea still. Why not? Okay? Your skin adds salt to the water. So all of a sudden you've gone from pure water to salt water. And as we just saw, salt water conducts. Water also increases the surface area and contact with the source of the electricity. Your skin itself is a fairly poor conductor. You also have all the ridges associated with your fingerprint, and that's why the water is increasing the surface contact area, because it's filling those in, and all of this. So now you have salt water and you have more area of contact. Your body on its own is about 9 parts per million salinity and about 70% water, and as such, it's a reasonable conductor. And I guarantee that the water coming out of the pipes in your house or dorm or wherever you happen to be is not pure. If nothing else, we know that water is chlorinated as part of the treatment process. We know that it's fluorinated. All these things that go into making your water drinkable so you don't get sick with it. So, summarizing, good conductors are metals. Some are better than others. Right? I certainly wouldn't want to wire my house with iron. Iron is not the greatest conductor in the world. Poor conductors are insulators, are rubbers and plastics and woods, and almost you can divide it under non-metals. Water, pure water, is a poor conductor, but it's very easy for water to not be pure and therefore become a much better conductor. This concludes this portion of Chapter 18. In the final portion, we're going to look at how things become charged.